Hey there! Ready to unlock some secrets of the mind.
Oh, I love that.
Today, we're diving deep into the world of psychological statistics and research methods.
Right.
Think of this as like your crash course in how researchers actually go about understanding human behavior.
Awesome.
We've got a syllabus from a master's program in applied psychology
Okay.
and some textbook excerpts.
All right.
Think greatest hits of research methods.
It's fascinating how these sources can really give you a glimpse into the detective work that goes into psychological research.
Okay, so let's unpack this. First things first.
Yeah.
What exactly is research?
Right.
I mean, we hear the word all the time, but what's really going on behind the scenes?
You know, it's more than just gathering facts.
Yeah.
Clifford Woody, a big name in the field, described it as this constant cycle of defining problems, testing ideas, gathering evidence, and drawing conclusions.
Okay.
It's like a never-ending quest to make sense of the world.
So it's like piecing together a puzzle.
Yes.
But the puzzle is human behavior.
Exactly.
Yeah.
And just like you'd use different tools for different parts of a puzzle, researchers have different approaches.
Okay.
Quantitative research is like taking a snapshot of a large group to see the big picture trends. But if you want to understand the nuances of individual experiences, that's where qualitative research comes in.
Okay.
It's like zooming in on a few pieces of the puzzle to see the intricate details.
I see what you mean. And sometimes you need both the big picture and the fine details. Right?
Absolutely.
Yeah.
That's where mixed methods research comes in, combining the strengths of both approaches.
Okay, so we've got our toolbox of research methods, but why does any of this matter? Why should we care about data and analysis and all of this?
Think about it this way. Research is the foundation of progress.
Okay.
In pretty much every field. It's how we solve problems, make informed decisions, and even understand ourselves better.
Yeah.
Without research, we'd be stumbling around in the dark.
That's a great point. So research is like shining a light on the mysteries of the human mind, helping us to see things more clearly.
Precisely.
Yeah.
And speaking of mysteries, what motivates people to embark on this journey of discovery in the first place? I mean, what drives researchers to ask questions and seek answers?
Well, I'm always curious to learn new things, to uncover those aha moments.
Right.
I bet a lot of researchers are driven by that same thirst for knowledge, right?
You're absolutely right. For many researchers, it's that inherent need to understand the world around them.
Okay.
But it can also be about solving real-world problems.
Yeah.
Challenging assumptions.
Right.
Or making a contribution to their field.
So it's like being a detective, but instead of solving crimes, researchers are solving the puzzles of human behavior.
And speaking of detectives, they have a system for solving cases, right?
Yeah.
Researchers have a system too, the scientific method.
Okay.
So let's get into the nitty-gritty.
Okay.
This syllabus lays out 10 steps in the research process.
All right.
It's like a roadmap for uncovering truth, wouldn't you say?
It absolutely is.
Yeah.
And just like a roadmap, it helps researchers stay on track and avoid getting lost in the complexities of their investigation.
So the first step is identifying the problem. It's like choosing a destination for your research journey.
Precisely.
Okay.
Once you know what you're trying to understand, you can start mapping out how to get there.
Okay.
Then you need to review the existing literature.
Right.
It's like doing your homework before embarking on a new adventure.
Right.
You don't want to waste time exploring territory that's already been covered.
That makes sense.
Yeah.
So once you've done your research, you need to set some clear objectives and hypotheses.
Right.
It's like setting a target for your research arrows.
Exactly. You need to know what you're aiming for.
Okay.
And a hypothesis is like an educated guess about what you might find.
Okay, so we've got our problem, we've done our homework,
and
we've set our targets.
Okay.
What's next?
Next comes choosing the study design.
All right.
It's like choosing the right vehicle for your research journey.
Yeah.
You wouldn't take a sports car on an off-road adventure, would you?
Definitely not.
No.
So researchers need to select the methods that best fit their research questions and their resources.
Exactly.
Okay.
Then comes the exciting part, collecting the data.
Oh, yeah.
It's like embarking on your research expedition and gathering those precious specimens.
I love that analogy. So researchers are out in the field, gathering observations, conducting interviews, or sending out surveys.
Precisely.
Okay.
And once they've collected their data,
Yeah.
They need to analyze it and draw conclusions.
So it's back to the lab to examine those specimens under the microscope, looking for patterns and insights.
Data analysis is where researchers use statistical methods to make sense of all that information they've gathered.
Okay.
And finally, they need to write the report.
So it's like writing a travelogue.
Precisely.
About their research journey, sharing their discoveries with the world.
They share their findings, their methods, and their conclusions, contributing to the ever-growing body of knowledge in their field.
Sounds pretty straightforward, right?
Well, in theory, yes.
Yeah.
But just like any good adventure,
research
can be full of unexpected twists and turns.
Right.
There are challenges along the way.
This syllabus actually mentions some common problems researchers face, particularly in India.
There's a lack of scientific training, not enough interaction between researchers, and even inadequate library management.
Those are all real challenges that can impact the quality of research. It highlights the need for investment in research infrastructure and training.
Right.
We need to support researchers and give them the tools they need to succeed.
Absolutely. Now, let's dive into the heart of research, hypotheses.
Think of a hypothesis as a detective's initial suspicion.
Okay.
It's a statement that can be tested to see if it holds water.
So we have the null hypothesis, which assumes there's nothing interesting going on, and the alternative hypothesis, which proposes a specific relationship between variables.
Right. It's like saying, okay, let's assume there's nothing to see here, but let's test that assumption and see if we find evidence to the contrary.
And then comes the data collection. That's when the researchers go out and gather those clues.
There are so many ways to collect data, each with its strengths and weaknesses.
Okay.
You've got surveys, questionnaires, interviews, observations, and even digging into existing records and documents.
It's like a detective's toolkit with different tools for different situations.
The key is choosing the right tool for the job.
Yeah.
An online survey might be perfect for reaching a large and tech-savvy audience, but you might need face-to-face interviews to really understand the experiences of, say, elderly individuals in a rural community.
It's about finding the best fit for your research question.
Precisely.
And the people you're studying.
And once you've collected your data, it's time to analyze it and draw conclusions.
So we're talking about turning raw data into meaningful insights.
And this is where it gets really interesting.
Okay.
But it's also crucial to be accurate.
Ethical. And avoid making generalizations that the data doesn't support.
It's like connecting the dots to see the bigger picture.
Exactly.
But being careful not to jump to conclusions.
Now, let's talk about a fundamental concept in statistical analysis. Correlation. Correlation tells us about the relationship between two variables.
Okay.
But here's the catch. Correlation does not equal causation.
That's a crucial point.
It is.
Just because two things are related doesn't mean one causes the other.
It's like the classic example of ice cream sales.
Oh, yeah.
And crime rates.
Right.
They tend to both go up in the summer. But does that mean eating ice cream makes people commit crimes?
Of course not.
Oh.
There's probably a third variable at play, like hot weather, that influences both.
So correlation can be a valuable clue, but it's not the whole story. And speaking of puzzles, there are different types of correlations, each measured by a specific coefficient.
Like the Pearson correlation coefficient, which measures the strength and direction of a linear relationship between two continuous variables. It's like seeing how closely two things move together on a graph.
I see. So a strong positive correlation means they move together in the same direction. While a strong negative correlation means they move in opposite directions.
And the closer the coefficient is to 1 or negative 1, the stronger the relationship.
Okay, that makes sense.
Then there's Spearman's rank correlation coefficient, which is used for ordinal variables where data is ranked rather than measured.
So if I ranked my favorite movies and you ranked yours, Spearman's correlation could tell us how much our rankings agree.
If we have similar tastes, the correlation would be close to +1.
Okay.
But if we have completely opposite tastes, it'd be closer to next to 1.
That's a fun way to think about it. So We've covered a lot of ground here.
We have.
From the basics of research to the intricacies of correlation.
Yes.
What's stood out to you so far?
What's fascinating is how research touches every aspect of our lives, from the products we buy to the decisions we make.
It's like research is working behind the scenes, shaping the world around us.
And remember, research is a journey of discovery.
Yeah.
Always asking questions, testing assumptions, and uncovering new knowledge.
So stay curious, keep asking questions, and never stop exploring. Now, let's move on to some of the specific ways researchers design their studies and gather data. First up, research designs.
This syllabus highlights several research designs, each tailored to address specific types of research questions. We'll start with experimental designs.
The gold standard for figuring out cause and effect relationships.
So it's like setting up a controlled experiment.
Exactly.
Their lab, right.
Researchers manipulate an independent variable to see its effect on a dependent variable while carefully controlling for other factors that could influence the results. It's like holding all the other pieces of the puzzle constant while you examine the relationship between two specific pieces.
Makes sense. But what if you can't manipulate the variables? What if you're studying something that's not ethical to control in a lab setting?
That's where non-experimental designs come in. These are used when manipulating variables isn't possible or ethical.
So instead of manipulating variables, researchers observe and measure them as they naturally occur.
For example, if you wanted to study the relationship between exercise and stress levels, you couldn't ethically
force people to exercise or experience stress. Instead, you might survey people about their exercise habits and stress levels and see if there's a correlation.
That makes sense. So you've got experimental designs for when you can manipulate variables and non-experimental designs for when you can't. But within those broad categories, there are a bunch of specific research designs.
Absolutely. This syllabus mentions several, like descriptive research, correlational research, and quasi-experimental research. Descriptive research is like taking a snapshot of a particular phenomenon. It describes what's happening without necessarily explaining why.
So it's like painting a picture with data.
Exactly.
And there's correlational research, which we've already touched on. It examines the relationship between two or more variables. But remember, correlation does not equal causation.
Exactly.
Just because two things are related doesn't mean one causes the other.
And then we have quasi-experimental research, which is like a hybrid between experimental and non-experimental designs. It's similar to experimental research, but lacks random assignment to groups, making it less rigorous, but often more practical in real-world settings.
It's like choosing the best tool for the job.
Precisely.
Depending on what you're trying to study. And what's feasible.
And once researchers have chosen their research design, they need to figure out how to collect the data they need.
That's where things get really interesting.
It is.
There are so many different data collection methods to choose from, each with its own pros and cons.
This syllabus highlights some of the most common methods, including surveys, questionnaires, interviews, observations, and document analysis.
It's like a research buffet.
Exactly.
So many options to choose from.
Surveys and questionnaires are great for gathering information from lots of people quickly and efficiently. They usually involve asking a series of standardized questions, either in person, online, over the phone, or through the mail.
That makes sense. But what if you want to explore individual experiences in more depth?
Then interviews are the way to go. They allow for more in-depth exploration of individual experiences and perspectives. They can be structured, semi-structured, or unstructured, depending on how much flexibility the researcher wants.
So if you want a lot of control over the questions, you go with a structured interview. But if you want to give the participant more freedom to share their thoughts and feelings, you go with a less structured approach.
Exactly. Then we have observations, which involve systematically watching and recording behavior in natural settings.
So if you're interested in studying social interactions, nonverbal communication, or cultural practices, observations would be a good choice.
It's like being a fly on the wall, observing behavior
I love that
as it unfolds naturally. And finally, there's document analysis,
Okay.
which involves examining existing records like letters, diaries, historical documents, or even social media posts.
It's like being a historian piecing together the past through documents.
Exactly.
So you've got these different data collection methods, each with its own strengths and weaknesses.
Right.
How do researchers choose the right one?
It depends on the research question, the target population, and the available resources.
Yeah.
Surveys and questionnaires are efficient for large samples,
Right.
but they may not capture the nuances of individual experiences.
Right, right.
Interviews provide rich data, but can be time-consuming and expensive.
Yeah.
Observations are great for real-world behavior,
Right.
but can be influenced by the observer's bias.
And document analysis can give you a window into the past.
Yes.
But those documents might not represent the whole picture.
Exactly.
Yeah.
Choosing the right data collection method is a crucial step in the research process.
Yeah.
It's about finding the best fit for the puzzle you're trying to solve.
All right. So the data's collected.
Yes.
Now what?
Now comes the fun part.
Oh, yeah.
Making sense of it all
right.
through data analysis.
Okay. I'm ready to dive in.
Awesome. It's like having a secret decoder ring for the language of data.
Okay.
Statistical analysis helps us uncover patterns, test those hypotheses we talked about, and draw conclusions from what can seem like a jumble of numbers.
Okay, I'm picturing myself as a code breaker now.
All right.
So what are some of the tools in this statistical toolkit?
Well, you've already encountered correlation coefficients, which tell us how strongly two things are related.
Yeah.
Remember, they range from -1 to +1. 0 means no relationship at all.
Right. Like the number of cats someone owns and their score on a math test.
Exactly.
Probably zero correlation there.
But I did something like hours spent studying an exam performance.
Yeah.
We'd expect a positive correlation.
More study time, likely a higher score.
And a negative correlation would be like more hours spent binge watching TV.
Yeah.
Probably fewer hours spent being productive.
You got it.
Correlation gives us a quick sense of how variables move together.
Okay.
But then we need to test if those relationships are meaningful.
Yeah.
Not just due to random chance.
Right.
That's where hypothesis testing comes in.
Right. We talked about the null hypothesis, the idea that there's no real effect. So how do researchers actually put that to the test?
They use statistical tests to see if the results they get are strong enough to reject that null hypothesis.
So it's like gathering evidence to see if there's enough to overturn the assumption that nothing's going on.
It's like a trial.
Okay.
And the statistical test is the judge deciding if there's enough evidence.
I like that.
To convict the null hypothesis.
I like that analogy.
And there's a whole range of statistical tests, each suited for different types of data and research questions.
Okay.
This syllabus mentions a few common ones like t-tests and N-of-A-L-A.
Those sound familiar, but can you refresh my memory on what they're all about?
Sure. The t-test is like a head-to-head comparison.
Okay.
Imagine you're testing a new drug to see if it reduces blood pressure.
Okay.
You'd have a group taking the drug and a control group taking a placebo.
Right.
The t-test would tell you if the difference in blood pressure between those two groups is statistically significant.
So significant enough to say that the drug is actually having an effect, not just random fluctuation.
Now, ANOVA is like a multi-way comparison.
Okay.
Imagine instead of just 2 blood pressure medications, you're testing 3 or 4.
Okay.
ANOVA would help you see if there's a significant difference among all those groups.
Okay, I'm starting to get the picture.
Good.
These statistical tests help researchers make sense of their data and draw conclusions that go beyond just gut feelings.
Absolutely. But it's crucial to remember that statistics are tools.
Okay.
They can be powerful, but they need to be used correctly.
Right.
Researchers need to understand the limitations of each test and make sure they're interpreting the results appropriately.
It's like using the right tool for the job and knowing how to use it.
Precisely.
Safely and effectively.
Now, this syllabus also highlights some of the challenges researchers face, particularly in India. Things like lack of proper training, limited access to resources, and even things like library management can impact the quality of research being done.
That's a good point. It's a reminder that research doesn't happen in a vacuum. The environment and resources available can make a huge difference.
Absolutely. It underscores the need for investment in research infrastructure and training to support researchers and help them thrive.
Okay, so we've talked about the tools and the challenges. But before we move on, I want to take a step back and ask, Why does all of this matter?
Yeah.
Why should we care about psychological statistics and research methods?
That's an excellent question.
Yeah.
I think the answer lies in the impact research has on our lives.
Right.
Even if we don't realize it.
I see what you mean. Research isn't just happening in ivory towers.
Right.
It's influencing our understanding of the world and ourselves.
Exactly. It informs our decisions, shapes policies, and leads to innovations that improve our lives.
Okay.
This syllabus mentions the role of research in fields like health education, business, and even government.
It's like research is working behind the scenes.
Absolutely.
Constantly pushing the boundaries of knowledge, shaping the world around us.
Precisely. So the more we understand about research methods, the better equipped we are to be informed citizens, critical thinkers, and even advocates for change.
That's empowering.
It is.
Now I'm curious about what drives researchers, what motivates them to ask questions, collect data, and seek answers.
Well, this syllabus highlights a few key motivations.
Okay.
For some, it's a deep-seated curiosity, a thirst for knowledge. Others are driven by a desire to solve real-world problems or to make a difference in people's lives.
I can see how all those things would be powerful motivators.
They are.
And sometimes it's probably a combination of factors, right?
Absolutely.
Yeah.
It might be a personal connection to a particular issue, a fascination with a specific area of study, or even the intellectual challenge of unraveling a complex problem.
Yeah, it's like all those things come together to fuel the fire of research.
Exactly. And it's important to remember that research is rarely a solitary endeavor.
Right.
Collaboration plays a huge role.
Okay.
Bringing together diverse perspectives and expertise to tackle complex questions.
So it's not just lone geniuses working in isolation.
Right.
It's about teams of researchers working together, bouncing ideas off each other, and pushing the boundaries of knowledge collectively.
Precisely. That collaborative spirit is essential for progress and innovation in research.
Now let's shift gears a bit and dive deeper into the research process itself.
Okay.
Remember those 10 steps we talked about earlier? It was like a roadmap for conducting research, starting with identifying the problem.
That's where it all begins.
Okay.
Defining the research question, setting clear objectives, and figuring out what you're trying to understand.
It's like setting off on a journey and choosing your destination.
Exactly.
Yeah.
And just like any journey, you need to do some planning before you set out.
Right.
That's where reviewing the literature comes in.
So it's like consulting your map and travel guides.
Yes.
Getting a sense of the terrain and what's already been explored.
Precisely. You want to see what's already known, identify gaps in knowledge, and build upon the work that's come before you.
Makes sense. What's next on this research roadmap?
Next comes setting objectives and hypotheses.
Okay.
It's like creating a more detailed itinerary for your journey, specifying exactly what you want to achieve and what you expect to find.
So the objectives are the specific goals of the study.
Yes.
And the hypotheses are those testable predictions about the relationships between variables.
Exactly. The hypotheses are where researchers put their theories to the test, making predictions that can be supported or refuted by the data.
So we've got our destination, our map, and our itinerary. What's next?
Next comes choosing the study design.
Okay.
It's like choosing the right vehicle for your journey.
Right.
The one that's best suited to the terrain and the conditions.
You wouldn't take a sports car on a mountain expedition.
Exactly.
No.
Researchers need to carefully consider the research question.
Yeah.
The resources available, and the ethical implications when selecting their study design.
So it's not just about choosing the most exciting method.
Right.
It's about choosing the most appropriate and ethical method.
Precise.
To the specific study.
And then comes the data collection phase.
Right.
This is where researchers hit the road, gathering information, using the methods they've chosen.
So they're out in the field conducting surveys, observations, interviews, or digging into existing records.
It's the data collection phase that breathes life into the research question.
Right.
Turning those abstract concepts into concrete observations and measurements.
I see. So the data is like the souvenirs researchers bring back.
I like that analogy.
From their research journey.
And just like souvenirs, the data needs to be sorted, cleaned, and organized before it can be truly appreciated.
Okay.
That's where data processing and analysis come in.
So researchers are back in the lab.
Yes.
Examining their findings, looking for patterns and meaning.
Exactly. They use statistical tools to analyze the data.
Right.
Testing their hypotheses and drawing conclusions based on the evidence.
Yeah.
This is where the decoder ring comes in handy.
Okay.
Helping them decipher the language of data and uncover hidden relationships.
It's like piecing together a puzzle.
Precisely.
But the pieces are data points.
Yes.
And the picture they reveal is the answer to the research question.
And once they've analyzed the data and drawn their conclusions, researchers need to share their findings with the world.
Yeah.
That's where writing the report comes in.
So it's like creating a travelogue.
Exactly.
Documenting their research journey, the challenges they faced, the discoveries they made, the insights they gained.
The research report is how researchers communicate their work to the wider scientific community.
Yeah.
Contributing to the ongoing conversation and advancing our understanding of the world.
Okay, so we've walked through the 10 steps of the research process.
We have.
From identifying the problem to writing the report.
Yes.
But I have a feeling it's not always a linear path, right?
You're absolutely right.
Yeah.
Research is often full of unexpected detours, roadblocks, and even U-turns.
Yeah.
Sometimes researchers have to go back to the drawing board, revise their plans, or even start over.
It's like any good adventure, you never know exactly what you're going to find.
Precisely.
Or what challenges you'll face along the way.
But that's part of what makes research so exciting and rewarding.
Right.
It's a process of constant learning, adapting, and refining our understanding of the world.
Now let's shift gears and dive into a specific aspect of the research process. Okay.
Data collection methods.
This syllabus highlights a variety of methods, each with its own strengths and weaknesses.
All right.
We'll start by looking at primary data collection, which involves gathering information directly from the source.
So it's like getting firsthand accounts from the people you're interested in studying.
Exactly. Primary data collection methods include things like surveys, questionnaires, interviews, and observations.
Okay, let's start with surveys and questionnaires. Those seem like pretty straightforward ways to gather information.
Surveys and questionnaires are particularly useful when you want to collect data from a large number of people quickly and efficiently. They typically involve asking a standardized set of questions, either in person, online, over the phone, or through the mail.
So it's like casting a wide net, gathering insights from a broad cross-section of the population.
But what if you want to go deeper?
To really understand individual experiences in more detail.
Then interviews are a better choice.
Interviews allow for more in-depth exploration, giving participants the opportunity to share their thoughts, feelings, and experiences in their own words.
I see. So surveys and questionnaires are like taking a snapshot of a group.
Yes.
While interviews are like having a one-on-one conversation to get a more nuanced perspective.
Exactly. Interviews can be structured, semi-structured, or unstructured, depending on the level of flexibility the researcher desires.
Okay.
A structured interview is like following a script, asking the same questions in the same order to every participant.
Okay, so that provides a lot of control and consistency.
Right. A semi-structured interview allows for a bit more flexibility, giving the researcher the freedom to ask follow-up questions or delve deeper into certain topics based on the participants' responses.
It's like having a conversation that flows naturally.
Exactly.
But with the general direction in mind.
And then there's the unstructured interview, which is like having a free-flowing conversation with a purpose.
Right.
The researcher might have some general topics in mind, but allows the conversation to unfold organically, following the participant's lead.
So unstructured interviews are more exploratory, allowing for unexpected insights to emerge.
Now let's move on to another fascinating method, observations. Observations involve systematically watching and recording behavior in natural settings.
So instead of asking people about their behavior, researchers are actually observing it firsthand.
This method is particularly useful for studying social interactions, nonverbal communication, and cultural practices. It's like being a fly on the wall, observing behavior as it unfolds naturally.
It's like getting a glimpse into the real world, seeing how people actually behave, rather than relying on their self-reported accounts.
Precisely, observations can be structured, unstructured, somewhere in between. In a structured observation, the researcher has a clear plan for what behaviors to observe and how to record them.
So it's like having a checklist of behaviors to look for.
Exactly. In an unstructured observation, the researcher is more open to observing whatever behaviors emerge, taking detailed notes and looking for patterns.
That sounds like it would require a lot of attention to detail.
It does.
The ability to make sense of complex interactions.
And then there's the semi-structured approach,
Okay.
which falls somewhere in between.
Right.
The researcher might have some specific behaviors in mind,
Yeah.
but is also open to observing other interesting things that happen.
Okay, so we've got surveys, questionnaires, interviews, and observations. That's a lot of different ways to gather data.
It is, and each method has its own strengths and weaknesses.
Right.
It's up to the researcher to choose the best method
Yeah.
or combination of methods to answer their research question.
Makes sense. Now, what about secondary data?
Okay.
What's that all about?
Secondary data is information that's already been collected by someone else,
Okay.
like government statistics, company records,
Right.
historical documents, or even social media posts.
So it's like using existing resources to answer your research question.
Exactly. Secondary data can be a valuable resource, providing insights into past trends, demographic patterns, or economic activity.
Right.
It can also be used to corroborate findings from primary data collection.
So it's like adding another layer of evidence to your research.
Yes, but wouldn't there be some limitations to using secondary data?
Right. Yeah, absolutely. It's crucial to be aware of the source of the data.
Yes.
The methods used to collect it, and any potential biases.
Right. Yeah.
You want to make sure the data is reliable and relevant to your research question.
Right. You don't want to base your conclusions on faulty or outdated information.
So whether researchers are collecting primary data or using secondary data, it's all about making smart choices and being aware of the limitations.
Precisely. Now let's shift gears and talk about making sense of all this data through data analysis.
All right, I'm ready to put on my analyst hat.
Data analysis is where researchers really get to dig into their findings and see what stories the data is telling.
I love that imagery.
I'm glad.
So what are some of the key steps involved in data analysis?
This syllabus emphasizes the importance of accuracy, ethical interpretation, and avoiding false generalizations. First and foremost, the data needs to be processed accurately. This might involve cleaning the data, removing errors, and organizing it in a way that makes it easy to analyze.
So it's like preparing the ingredients before you start cooking.
Exactly.
You want to make sure everything is fresh, clean, and ready to go.
Then comes the interpretation phase. This is where researchers use statistical methods to make sense of the data, looking for patterns, trends, and relationships.
It's like examining those ingredients, tasting them.
I like that analogy.
And figuring out how they work together to create a delicious dish.
And just like a good chef wouldn't over-season a dish. Researchers need to be careful not to over-interpret their findings. They need to be honest about the limitations of their study. And avoid making generalizations that the data doesn't support.
It's about staying true to the evidence and not jumping to conclusions that go beyond what the data can actually tell us.
Now let's delve into some specific statistical methods that researchers use to analyze their data.
I'm ready to learn the secrets of the statistical trade.
But you've already encountered one of the most fundamental ones. Correlation.
Correlation, right.
Correlation tells us about the relationship between two variables. And we talked about how correlation doesn't necessarily equal causation. But even when there's no causal link, correlation can still be very informative. It can help us identify patterns and make predictions, even if we don't know the underlying reasons for those patterns.
It's like seeing the footprints of a relationship.
I like that.
Even if we haven't met the couple yet.
Now let's talk about some statistical tests that researchers use to go beyond just correlation and see if there are significant differences between groups.
Those are the t-tests and ANOVA we talked about earlier, right?
You got the t-test is used when you want to compare the means of two groups. Like comparing the test scores of students who used a new study technique versus those who used a traditional method.
And ANOVA is used when you want to compare the means of 3 or more groups.
Precisely like comparing the effectiveness of 3 different types of therapy for anxiety. These statistical tests are like powerful magnifying glasses. Helping researchers see subtle but important differences in their data.
I'm starting to see how all these statistical tools fit together.
Good.
They're like pieces of a puzzle, each providing a different perspective.
Yes.
And helping us build a more complete picture of the phenomenon we're studying.
This is fascinating.
But with all these statistical tests and methods, it seems like there's a lot of room for error. How do researchers make sure their findings are accurate and reliable?
That's a great question. It all comes down to careful planning, rigorous methods,
Yeah.
and a healthy dose of skepticism.
Okay, so it's not just about plugging numbers into formulas.
No.
It's about thinking critically about the data and the methods used to collect it.
Exactly.
Mm-hmm.
Researchers need to be aware of potential biases,
Right.
limitations of their study,
Mm-hmm.
and the assumptions underlying the statistical tests they use.
Yeah.
It's about being transparent about those limitations.
Right.
And interpreting the results in a way that's honest and nuanced.
So it's like being a detective, but also a judge.
I like that analogy.
Carefully weighing the evidence and making sure the verdict is fair and just.
Now let's move on to the final stage of the research process.
Okay.
Drawing conclusions.
The data's analyzed, the hypotheses have been tested.
Yes.
What happens next?
This is where researchers step back from the numbers and think about what it all means.
Okay.
They consider the implications of their findings,
Yes.
not just for the research question,
Right.
but for the wider field of study
Mm-hmm.
and even the real world.
So it's about connecting the dots between the research findings and the bigger picture.
It's about answering the so what question.
Right.
Why do these findings matter?
Yeah.
What do they tell us about human behavior?
Yeah.
How can we use this knowledge to make a difference?
Right. Research isn't just about collecting data for the sake of it.
No.
It's about using that data to understand the world and ourselves better.
Precisely.
Right.
And drawing conclusions isn't just about summarizing the findings.
Yeah.
It's also about acknowledging the limitations of this study.
Right.
Suggesting directions for future research.
Mm-hmm.
And thinking critically about how the findings fit into the existing body of knowledge.
It's like adding a new piece to the puzzle of human understanding,
Exactly.
but also recognizing that the puzzle is far from complete.
Research is an ongoing journey.
Right.
And each study contributes a piece to the ever-evolving picture.
Now let's talk about the final step in this process,
Oh, hey.
writing the report.
Ah, yes, the grand finale.
Yeah,
Where researchers get to share their discoveries with the world.
exactly. The research report is how researchers communicate their work
Yes.
to the wider scientific community.
Mm-hmm.
It's a detailed account of the research journey,
Right.
from the initial research question to the final conclusions.
It's like creating a documentary.
I like that.
But instead of exotic locations,
Yeah.
researchers are exploring the landscapes of the human mind.
I love that analogy. A well-written research report should be clear,
Yes.
concise, and engaging,
Mhm.
even for readers who aren't experts in the field. So it's not just about presenting the facts and figures. It's
Right.
about telling a compelling story about the research process,
Yeah.
the insights revealed.
Precisely. And it's crucial for researchers to be transparent
Yeah.
about their methods, their findings,
Mm-hmm.
and any limitations of their study.
So it's like laying all your cards on the table,
Exactly.
wanting others to examine your work and build upon it.
Transparency is essential for fostering trust and collaboration
Right.
in the scientific community.
Okay, so we've explored the research process from start to finish.
We have.
It's amazing to see how much thought, planning,
Yeah.
and rigor goes into every step.
Mm-hmm.
But what about those aha moments?
Oh, yeah.
The surprises that make research so exciting?
Right.
Do those happen often?
They absolutely. Research is full of unexpected twists and turns. Sometimes. They absolutely do. Research is full of unexpected twists and turns. Sometimes the most fascinating discoveries come from those unexpected findings,
Mhm.
the things you weren't even looking for.
It's like stumbling upon a hidden treasure while you're exploring a new path.
Exactly. And those moments of surprise and discovery are what keep researchers going, fueling their curiosity and driving them to explore even further. Now, let's talk about one of the fundamental concepts in psychological research hypotheses.
Ah, hypotheses. Those educated guesses that guide researchers' investigations. It's like having a hunch and then setting out to prove or disprove it.
Exactly. A hypothesis is a testable statement that proposes a relationship between variables. It's what we aim to support or refute through research.
So it's like a roadmap for the research journey.
Precisely. This syllabus delves into different aspects of hypotheses, including how researchers formulate them, how they test them, and how they interpret the result.
Okay, let's break it down. What are some of the key things to know about hypotheses?
Well, we need to start with the null hypothesis, often denoted as H0. This always assumes there's no relationship between the variables being studied. It's like starting with a clean slate, assuming there's nothing interesting going on.
So it's like the innocent until proven guilty principle in research.
Precisely. But then we have the alternative hypothesis, denoted as H1, or HABI. This proposes a specific relationship between the variables. This is what researchers often hope to find support for.
So the research process is like a trial with the null hypothesis on trial, and the researcher is presenting evidence to try and prove the alternative hypothesis.
I like that analogy and statistical tests are like the jury helping us decide if there's enough evidence to reject the null hypothesis.
That makes sense. Can you give an example?
Sure. Let's say we're studying the effects of a new therapy for depression. The null hypothesis would be that the therapy has no effect on depressive symptoms. The alternative hypothesis might be that the therapy reduces depressive symptoms.
Okay, so researchers would gather data from people undergoing the therapy and compare their symptoms to those of a control group who didn't receive the therapy, and the statistical tests would help them determine if the differences they observed were significant enough to reject that null hypothesis.
Exactly. And this syllabus highlights the importance of statistical tests and hypothesis testing. They help us determine if the results we observe are statistically significant, meaning they're unlikely to be due to random chance.
So if the results are statistically significant, it's like the jury has found enough evidence to say, hey, something's going on here. The null hypothesis is probably wrong.
Exactly. But if the results aren't statistically significant, it doesn't necessarily mean the null hypothesis is true, just that there isn't enough evidence to reject it.
It's like the jury saying, we're not convinced there's not enough evidence to convict the null hypothesis.
I like how you're thinking about this like a courtroom drama. It's a great way to understand the process.
Okay, so we've talked about the null hypothesis and the alternative hypothesis. Are there other types of hypotheses researchers use?
There are. This syllabus mentions simple hypotheses, which propose a relationship between just two variables, and complex hypotheses, which involve three or more variables.
So a simple hypothesis might be something like eating breakfast improves concentration, and a complex hypothesis might be something like eating breakfast combined with getting enough sleep and exercising regularly leads to better academic performance.
Exactly, you're getting it. Then there are associative hypotheses, which propose a relationship where variables simply change together without implying one causes the other.
Right, we talked about that with correlation, like ice cream sales and crime rates both tend to go up in the summer, but that doesn't mean eating ice cream causes crime.
Exactly. There's probably a third variable at play, like hot weather, that influences both.
And then there are causal hypotheses, which do propose a cause and effect relationship between variables.
Right. Those are often more challenging to test because you need rigorous methods to rule out other possible explanations.
So a causal hypothesis might be something like exposure to violent media increases aggression in children, but testing that would involve carefully controlling for other factors that could also influence aggression, like family background or personality traits.
Precisely understanding the different types of hypotheses helps researchers formulate clear research questions and design studies that effectively address those questions.
Okay, so we've got our hypotheses, we've designed our study. What's next on the research agenda?
Now it's all about making sure we get accurate and reliable results, and one of the keys to that is experimental control.
Experimental control, that sounds pretty important. What's it all about?
It's about minimizing the influence of extraneous variables, those sneaky factors that could mess with our results and lead to inaccurate conclusions.
So it's like eliminating distractions so you can focus on the signal, not the noise.
Exactly. This syllabus emphasizes controlling for things like age, gender, socioeconomic status, and prior experiences depending on what you're researching.
Okay, I see how those things could skew the results if you're not careful. Can you give an example?
Sure. Imagine you're studying the effects of a new teaching method on student performance. If one group happens to have a bunch of students who already excel in that subject, while the other group has mostly struggling students that could unfairly influence the results, making the new method seem more or less effective than it actually is.
Right. It's like comparing apples and oranges. So experimental control helps us make sure we're actually comparing apples to apples.
Exactly. It helps us isolate the true effects of the variable we're interested in this case, the new teaching method.
Yeah, so how do researchers actually achieve this experimental control? What are some of their secret weapons?
Well, this syllabus mentions a few key techniques, including randomization matching and holding variables. Constant randomization is a powerful tool. It involves randomly assigning participants to different groups, so any pre-existing differences are spread out evenly.
So it's like shuffling a deck of cards to make sure the game is fair.
Exactly. It helps minimize bias and makes it more likely that any differences we see are really due to the manipulation we're doing, like that new teaching method.
That makes sense. What about matching? What's that all about?
Matching is about pairing up participants based on certain characteristics like their age, gender, or skill level, and then putting one member of each pair into each group.
So if you had two students with similar math abilities, you put one in the group using the new teaching method and the other in the control group.
Exactly that way. The groups are similar on those key characteristics, so those variables are less likely to influence the results.
Okay, so randomization is about spreading out differences randomly, and matching is about intentionally creating similar groups. What about holding variables constant?
That's about keeping certain factors the same across all participants or groups. For example, in our teaching method study, we might hold the classroom environment, teaching materials, and instructor constant.
So you're eliminating those things as potential variables, making sure they don't influence the outcome.
Precisely. Experimental control is all about creating a level playing field so we can clearly see the effects of the variable we're manipulating.
It's like creating a controlled environment where the only thing that's different between the groups is the variable we're interested in studying.
Exactly. Now let's talk about another crucial aspect of research design sampling.
Sampling, that's about choosing who participates in the study, right?
Exactly. It's about selecting a subset of individuals from the larger population we want to understand.
Okay, so it's like choosing a representative group to stand in for the whole population.
Precisely. And this syllabus really emphasizes the importance of representative sampling. That means our sample should accurately reflect the characteristics of the population we're interested in studying.
So if you're studying political attitudes in a country, your sample should include people from different regions, age groups, socioeconomic backgrounds, and political affiliations.
Exactly. It's like creating a mini version of the population, so our findings can be generalized to the larger group.
That makes sense. What are some of the ways researchers ensure their samples are representative?
Well, there are a bunch of different sampling techniques, but some common ones include random sampling, stratified sampling, and convenience sampling.
Okay, let's break those down. What's random sampling all about?
Random sampling is often considered the gold standard. It means every member of the population has an equal chance of being selected, like drawing names out of a hat.
That seems pretty fair. It helps ensure that your sample isn't biased towards any particular group.
Exactly. It's a great way to get a representative sample. But it can be challenging to pull off in practice, especially if your target population is large or spread out.
Okay, so what about stratified sampling? How's that different?
Stratified sampling is like taking random sampling a step further. It involves dividing the population into subgroups based on certain characteristics and then randomly selecting participants from each subgroup.
So if you wanted to make sure your sample included an equal number of men and women, you could divide the population into those two groups and then randomly select participants from each group.
Exactly. That way your sample would reflect the gender breakdown of the larger population.
Okay, so random sampling and stratified sampling are all about getting a representative sample. What about convenience sampling?
Convenience sampling is about selecting participants who are readily available. It's often used when researchers have limited resources or time.
So a researcher might use students in their psychology class as a convenience sample.
Exactly. It's a practical approach.
Right.
But it can introduce bias if those readily available participants aren't truly representative of the larger population, like psychology students might have different characteristics than the general population.
Right, so convenience sampling is a trade-off between practicality and representativeness.
Precisely the choice of which sampling technique to use depends on the research question, the target population, and the resources available. And researchers always need to be aware of the potential limitations of their chosen method.
It's like choosing the right tool for the job, considering both the advantages and disadvantages.
Exactly. And that brings us to the end of our deep dive into the fascinating world of psychological statistics and research methods.
Wow, we covered a lot of ground. It's amazing to see how much goes into designing and conducting research, from formulating hypotheses to analyzing data and drawing conclusions.
It's a complex but rewarding process, driven by curiosity, a thirst for knowledge, and a desire to understand the complexities of human behavior.
I'm definitely feeling more informed and even more curious about the world of research. What are some key takeaways you hope our listeners will ponder as they continue their own journeys of discovery?
I hope they'll walk away remembering that research is all around us, shaping our understanding of everything from health and education to the products we buy and the decisions we make. It's a powerful tool for understanding the world and ourselves.
Absolutely. And even if we're not all researchers, we can all benefit from thinking critically about the information we encounter, questioning assumptions, and seeking evidence to support claims.
Well said. Remember, knowledge is power. And the more we understand about how research works, the better equipped we are to navigate the complexities of the world around us.
That's a great reminder. Thanks for joining us on this deep dive into psychological statistics and research methods.
It's been my pleasure. Keep those minds curious and never stop exploring.